Welcome to this video lecture. My name is Mark Scythian. The date today is March 7, 2024. So in this particular lesson, we will discuss predictive modeling within the exponential and natural log functions pertinent to calculus rates of change. So assume you have a business, and in the first month of the fiscal year, a revenue of $25,000 in the first month was accrued. And by the end of the year, in month 12, $75,000 of revenue was accrued. So between the start month and the end month, we have a growth factor of revenue occurring based on past behavioral or financial patterns. So this can translate to a threefold increase in revenue, 75,000 divided into 25,000, made equal to an exponential function where A is the growth or decay factor taken to the exponential value of the final month, so a to the 12th power, over the change from the initial start of the growth factor A to the first power or to the first month. So abiding by the rules of dividing exponential functions, we're left with a value of a to the 11th power made equal to 3. So to compute the growth factor, we need to solve for a. In order to cancel out the 11th power, we need to apply it to the 11th root. So upon doing so, we have a is equal to the 11th root of 3. This is entered into your calculator as the parentheses quantity of 3 taken to the 1/11th power, or the 11th root of 3. This translates to a growth factor of 1.105. So now we can apply this into an exponential KT function to predict the revenue behavior into the future or after month 12. This is formatted by starting with the initial value at month 1 times the exponential function taken to the KT power. So we need to solve for the K constant of this growth factor. So we can apply it to the natural log of the growth factor 1.105, which computes the K constant, or 0.0998. So then the equation to model the past behavior is now complete. So we have the function of 25,000 e to the 0.0998 t power. So now we can test this equation describing the previous financial / revenue behavior to predict the future outcomes or predictive model, assuming that these revenue patterns stay consistent as they have been in the past 12 months. So upon spot checking the equation for the revenue at month number 5 based on the yearly pattern, month 5, represented by t is equal to 5, is entered into the equation. So the y output is equal to 25,000 e to the exponential 0.0998 times 5 for month number 5, this yields 41,176 and 83 cents. So now the spot check has been completed. This equation can also be put into a graphing calculator to establish a graphical curve for presentation sakes. So now if we apply the predictive model for the revenue generated at month 15 or 3 months after the end of the year based on consistent patterns, we then have that data computed as Y output is equal to 25,000 e to the 0.0998 times 15 for month number 15, which will yield 111,706 and 60 cents at month number 15. So the natural log and exponential KT power functions within calculus rates of change modeling can be applied to accurately predict future outcomes from previous behavioral patterns. Thank you for watching this video lecture/lesson, and have a great day.